For today's quiz, we're going to introduce a new chip. It's a 417. It's a decade counter, decade being 10. This counts to 10. And we're going to use our 555. Now, before you stop the video, if you're a teacher and before you say, I can't do this, I promise you can. This is not as complicated as it looks. It looks pretty bad, I'll give you that, especially when I show you this. But once you do just a part of this, you'll see it's the same thing over and over. So I promise you this is going to be big payoff for your students. Regardless, we're going to use our 555 chip, which we've already shown how to use in another video. But if not, you can just do it right now. And we're going to end up sending the output from pin 3 over to pin 14 on our 417. I have on our quiz right here the chips vertical. Sometimes it's easier to put them on their side, as I'm going to show you. Let me just give an example of what a 555 and a decade counter can do together. I wanted to make an illusion where, you know, if we had airplanes coming down to land on a runway, they know which direction they're supposed to be landing. Are they landing from this side or this side? So what we're going to do is we're going to end up having the LEDs. Each output will go 0 and then 1, 2, 3, 4, 5. So it'll make this pattern. And I have it going really fast, which is simple enough to set. All right, here we go. So I've got this neat little pattern, if you can see it, kind of going from side to side here. And my 555 chip is right here, and there's my 417. We're going to show you how to put all this together, I promise. But our quiz is really asking, there was an old TV show. It was called Knight Rider. And Knight Rider was just a car, and it was advanced technology, and it was very popular back in the day. Whatever. On the front of the car, they had the lights that would go back and forth, back and forth. That's our challenge for the students today. Can you use this with the outputs? And I'll explain in just a second. Can you make the LED output go back and forth? You might be saying, I can't even build this circuit, but there's an old expression that perfection is the evil of good, something like that. Think of perfection of understanding or complete understanding as being the impediment to learning new features of electronics and electricity. So don't let it stop you that you don't understand everything. Just jump in. Your brain will fill in gaps as you go along. Let me point out that these are outputs. This is the only tricky part. Whenever I have a chip, just like our 555, we start and count clockwise. Output 1, 2, 3, 4, 5, 6, 7, 8. On our 417, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Just like before. But I've just labeled the outputs as where is our first output and our second output as it counts. So pin 3 is actually your 0 output. So it's going to end up, anytime it has a 0, it's going to output from here. And I have a little resistor in the LED. In other words, for every 10 pulses of that 555, this would light up once. And then if I wanted to do it the other sequence, I could say 0, and then I want the next one to light up. I'd put an LED with a resistor right here down to ground. So as it started counting again, this would light up, then this one would light up. And if I did my third one, which because we started at 0, I would do the second, it would go blink, blink, blink. So in other words, we're going to count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we go back to 0. And you might be asking, why didn't the engineers just make this in order? Well, remember, this is going to be lithography, and making these chips is very difficult and rather complicated. So we'll have to show you the diagrams and dies of how these work. Anyhow, all we're asking your students to do is we've got 10 LEDs. Can they design the outputs so that we would end up going back and forth? This is what your quiz looks like. I'll hold it up now. And I had to use the whole sheet. You'll also notice that because the pins can be so confusing with the outputs, I didn't bother putting them on this side. And remember, all of these are available at www.idealizescience.org, and you can download these PDFs. All right, let your students see what they can do. Typical student responses are going to be, A, I'm totally confused, I don't know what to do. That's okay, just hang on. Now, a few of your students are going to really impress you. They'll say, all you're asking us to do, we don't really have to understand any of this. You just want to know how to line up the outputs so I get that pattern. This type of dialogue will then set everyone at ease, and you'll get more and more students discussing this. Other students will simply then jump in and say, oh, all we have to do is take our first output, put it here, and then our second output, put it here, and our third here, and so on. And then someone might ask, well, how do we get it to go back? So your students are all going to work together trying to solve this problem. So don't give up on them. Give them a little bit of time, and as they need hints, give them hints. As your students are conversing back and forth, students are going to start saying, oh, why don't we just figure out our numbers that we want to light up? Picture each one of these dots as being an LED. So one of your students might say, why don't we just do 1 and then have 2 and then our third LED from our output 3 and then 4 and then 5 and then we could do 6, 7, 8, 9, and that's where they'll get stuck. They'll say, wait. I did 1 through 5 and then I come back. Another student will say, you forgot to start at 0. So look, they're going to build on these ideas. Another student is finally going to end up jumping in and saying, wait, we're going to have 2 rows of LEDs going back and forth. They might say, why don't we end up sending output 5 and also 6 to a single LED? And that is going to be major progress, because now the students are going to realize I can just use a few LEDs instead of all 10. I can use the same LEDs twice. So they're probably going to end up having fun on this. And remember, they are going to enjoy when they build this and get this to work. So there's going to be really big payoff. All right, so let's see what they can do. Your students are going to end up getting really in deep about this idea. Most of them are going to realize that using just a few, maybe half of the LEDs is going to be much better than using all of them. So we're going to have them come over and then swing back. We already have a student that said we should end up using 1, 2, 3, 4, 5 LEDs and then have that go back and forth. Others will say, wait a second, if I ended up adding the 0, because I should have started at 0. So I'm going to rewrite this. Another student might come up and say, why don't we do 0, 1, 2, 3, 4, and then we can do 5, 6, 7, 8, 9, like that. Now you can get away with 5 LEDs. And the students are thinking very deeply about this. And remember, they don't even need to know all this electronics. Now they're just solving the problem at hand. Look, what's going to happen is we're going to have this bulb is going to light up, and then 1, 2, 3, 4, but watch, 4 lights up, and then 5 lights up, and then you got 6, 7, 8, 9, and then this one lights up. So in other words, our pattern, someone's going to realize, look, our pattern's not going back and forth, it's going over, stopping, and then coming back and stopping. So another student is going to end up saying something that's going to seem blasphemous at first. They're going to say, we can't just have 5 LEDs going across here. We're going to need 6. And the students are going to say, there's no way. What are you talking about? And this is where it's going to be really important for them to get to the board in front of everyone and describe what they're thinking. And it turns out they're right. So far, I've been acting as if there's a single solution to this. In electronics, there isn't a single solution. There's multiple. And this is where your students can be creative. They can come up with ideas that you never thought possible. So it's an excellent exercise for them to be working on electronics. Let's talk about this 6 LED idea. It's a good one. Look, we can end up saying 0, and then we can have our 1, 2, our 3, our 4, and then our 5. So notice it's actually 6 numbers. 1, 2, 3, 4, 5, 6. Now, where would 6 go? I don't want to get stuck on this side. I don't want to go over, stop. I want to keep smoothly going back and forth. So what we can do is 6 could end up being right here, using the same LED as 4, and then 7, 8, 9. And that right there seems like a really good solution. So let's try and put this together. All right, I'm sitting at a desk so we can look the circuit over. You'll notice that I'm going to put the components right where they should be on the diagram, and then from there I'll use a breadboard and start putting all this together. Since I didn't specify the values, I'll run back over to the board, give you those values, and then we'll come back and put this together. Let's go ahead and put some values in here. You can really vary these greatly. I'm going to say 100,000, but if you have a 10,000, use a 10,000. And you can work them back and forth to get whatever rate that you want. We'll change that when we're done. But just to start off with, let's make this 100,000. Put kilo ohms. Let's make this 100,000 kilo ohms, mainly because we did that before, and we'll just keep it consistent. This little capacitor here, why don't we just make that a 1 microfarad, and then let's make this a 330 ohms. If you have a 1000, use 1000. If you have a 220, use a 220. They're LEDs, they're cheap. If you burn one out, which you probably won't, if you have any kind of resistor there, it's going to work fine. We can get a little bit more tuned in later. This one I'm going to use 220s. 220 ohms, and this resistor here. Now you'll notice this is ever so slightly different than our diagram. Our diagram, I had this going to the side, right across the top. It's not a big deal. This little capacitor here just helps stabilize the circuit. I just happen to have a 22,000 kilo ohms that was laying out. Anything in the tens of thousands will work fine. It'll probably work even if you didn't put that in there, quite honestly, but we're going to put it in. And let's see, is there any other values? This cap, we just use like a 0.1 microfarad. And once we put this together, sometimes there's a little bit of a tolerance for every one of your components and every one of your chips. And maybe one chip, you're doing everything exactly you did before, and for whatever reason, it's just past the threshold of what it can do. You might want to just change one of those values. Is there anything else that we want to specify? I think that's good. And I'm going to be using a 6-volt battery again. All right. Let's go back to the table and see if we can put all this together. All right, so I'm simply going to move this sheet over. And if you're a teacher and you don't have a lot of money for your classroom or whatever, consider getting one of these kits. They're just a bunch of different wires of different colors. Colors mean nothing. They're just different lengths. And if you don't like that system, or you can find a different set of jumper wires, feel free to use whatever you can get. So we're just going to jump in, and we're going to start using a breadboard. Highly recommend using a breadboard for this project. You'll notice that I've got a negative rail and I've got a positive rail. And I'm going to start with those, and I'm going to put a red wire and a brown wire. That's normally what I do. And then I'll put my chip in. I'll just find a happy spot for them, put them in, and we're just going to build from here. Okay, we're going to put this 555 together. First thing we should probably do is get our rails for positive and negative. I'm going to power my chip. I'm going to put a red right into our pin 8, and I'll take it over to one of these rails right there. That's in good shape. I can also take one of these orange wires and take a negative straight over to my negative rail. Push those in. I can now take my capacitor. My capacitor is going to end up being a 1 microfarad. Long leg is positive, so it goes into 2, and the short leg would go into 1. Let's go ahead and put our 4 to 8. So I'll put that side into 4, put this side into 8, and I'll just jump straight across that chip like that. And I'll also do the same thing with my 2, and I'll go right to 6 right here. Push those in. I'll take my 100,000 ohm resistors. I'll put those between 7 and 8, and 8 to 7. 8 to 7, and then 7 to 6. Normally we cut these to make them a little bit easier to get into these slots, but not all teachers are going to have enough of these to cut, so we won't do it either. I'll then take a resistor, and which capacitor did I just put in there? Just making sure. I'm going to take that one out. I think this is the one that we had set aside, 1 microfarad. So the longer leg would be more positive, so I'll put that in 1, 2. Shouldn't really make a difference. From 3, I'll just take and put somewhere else where I can pick up a rail for my LED. The more positive or the longer leg goes to the resistor. The other side goes into ground. Let's go ahead and just check to make sure our 555 is blinking. If it's not, then we'll rebuild it. But we don't want to go on before it's working. Okay, so that works well. So now we're just going to take our chip over, our counting chip, our decade counter, and I'll just put that anywhere that seems like I have a little bit of open space. Don't bend the legs. Make sure they're all going in before you press all the way. Now I need to power this one. So I'll put pin, 16, and I'll go right over to the rail here like so. It's not beautiful yet, but we'll be okay. And then, of course, I'm going to need a little capacitor there. I think we said we would use the 0.1, and that's what this is. So the more positive side goes to the positive side. That's the longer leg, so I'll just put those right there. If you recall that I have on pin 15, I'm going to take that over to what was ground over here, but I'll just take it straight over to my negative rail right there. Same thing, 22,000. And from there, I need to also pick up a negative for that chip, and I'll just take this last chip, which is number 8, which is going to be VSS, which in this case is just ground, but put that in there. So our chip is now powered. We can then start to take, let's see, we need to take our clock function. In other words, we need the output from pin 3 right here. I'll just take pin 3 from our 555 and take that over to our clock, which is 14. 16, 15, 14. I'll just put it right in there. And now that chip will start to count for us. Now let's make sure we have everything. Oh, I forgot between, looks like our 12 and ground, I need a carry out. So let me grab another one of these browns. Let's see, 12, 1, 2, 3. This is not long enough, so let me get a maybe a brown here, and I'll just jump right over top. So that would be 9, 10, 11, 12, and I'll just jump right over to ground there. So I've got this taken care of, I've got that taken care of. I am connected to my 555 via this yellow wire. Oops, move that over a little bit. I've got my capacitor in there, so everything is looking good. Now what I'm going to do is I'm going to end up starting to take all of my outputs, and I want to start thinking ahead. I want to end up having all my LEDs down here. So that's what I'm going to do. I'm going to get them all set up, and then I'll bring individual wires over. So let me just show you one. If I go to pin 3, 1, 2, 3, that's going to be my output. I'm going to start that right here. I'll put that right over here. And then I'll take one of my 220s right next to it, and then I'll just jump over here like so, and then I can put an LED in here, and that way I can start to line them up. 1, 2, 3, 4, 5. Maybe we'll go to 10 at first. Let's plug this in and see if it's going to count. Now, it should only count every 10th one. So it counted, and look, every 10th one it lights up. So what I'm going to do is I'm going to very quickly put all the rest of my LEDs in here and my resistors and just get them ready, and then I'll start pulling all the wires. All right, we're back, and I have all my resistors lined up. They're each going to an LED, and now what I'll do is I'll just continue what we were doing before. You'll notice that I started with the 0, and that's going to be our first light, and we can just double check to make sure that's working. I had to replace that small wire with a smaller wire, I should say, because I need longer ones for later. It's working, so I'm going to continue along. Notice 1 is going to be right above it, so I'll end up just plugging right into there, and then right next to that first one, and it's a little bit of a stretch, but that wire seems okay. And then I can end up doing number 2, which is 1 the other direction from our 0. See if that fits in, and it does. And then I can do, so what are we up to? We're up to 2. Now I got to do 3, which is going to end up being my 7, and 7 is just 1 from my ground. Let's see if it'll reach here, and I think it does. Plug that in there, and now I'm going to do 4, which is from our 10. So that is 9, 10. So right there plugs into here. It's a little hard not looking directly above from above, but anyhow, 5. That's 1. That's all the way from pin 1. Now that goes into our next LED, and then 6 is going to be 5. So we're going to end up going right here. So that is going to end up being here. And 7 is the one right after that, the 3rd pin in, and it is open, so I think I'm doing it right. Plug that in, and then 8 is all the way at the end here. Hopefully I'm getting these. 8. And then I just need number 9, which is the 3rd pin up here. So hopefully that's it. I gotta stand to see this one. And let's plug it right in here. So now when we have this, it should be counting up for us. And that was what I originally had showed you. So let's see if it works now. I plug this in. And there it goes, in order. Now, if I wanted to speed these up, I might be able to change the capacitor out on the 555 so it speeds up a little. I don't know if it'll be able to. Let's try it out. I'll simply take this capacitor out, and this is a 1 microfarad, and I'll put a smaller, that is a 0.1. Let's see if it's able to handle it. Might be at the limit of this circuit. The more positive goes here, so. We'll try that out, see if it goes any faster. There we go. Now it makes a pretty display, and that's what I showed you to begin with. So now what we can end up doing is we can end up trying to make that Night Rider. But either way, this is a really nice circuit for your students. They're going to love this, and they can end up changing the capacitor and the resistances, and they can end up making this go faster or slower. All right, let's try the idea that we were talking about having 2 leads going to each LED. All right, we've got our runway strip. This is the original circuit that I had built before. I actually like the bulbs spread out a little bit, but your students can play with that. Now we're going to try and see if we can make that Night Rider. Even if we couldn't, this would be pretty rewarding in itself. So all we need to do now, according to what we were thinking, is simply leave 0, 1, 2, 3, 4, 5, and then as we come back, we'll take 6 with 4, 7 with 3, 2 with 8, and 9 with 1. Now, how are we going to remember that? Well, they add up to 10, so let's go try that. All right, I'm going to move my circuit over a little bit here. I've got 0, 1, 2, 3, 4, 5. So I'll take my 6 right here. The 6 we said is going to go back with number 4. I'll put it right in front. And then my 7 would go with 3. My 8 would go with 2. I'm going to put it in the back here. Now, maybe I'll see if I can, yeah, I'll put it in the back. And then this one goes right here. Okay, moment of truth. Let's see if it works. Let's see if we can get this Knight Rider. Now, it's only going to illuminate these first 5, so I'm just going to cover these up. Let's see if it works. And lo and behold, it goes back and forth, back and forth. And that might be a little bit too fast. I'll take and I'll simply rearrange. I'm sorry, I'll put the other capacitor of my 555 back in. Got stuck for some strange reason. And 555, like that. That should slow it down a little. Let's see if it's easier to see. There we go. Back and forth, back and forth. All right, so it does work. Okay, we've got the original circuit and we've got our new Knight Rider circuit. So we've made 2 using the same basic idea. It's a fun chip, this 417, and you can keep going and going and going and building new things with this. Now, I want to point out we're not done with this. You'll notice that when I get to my 2 extremes, 0 and 5, they're a little bit brighter here. Remember, we've hooked 2 together and trying to feed power back into a chip. So my next step, which we're not going to do now, but I would replace all those resistors or simply add a diode with each one of those so they're not trying to end up push power back into those chips. But again, it's a never-ending saga with electronics. As soon as you're done with something, you end up getting another project. So it's an awful lot of fun. So, all right, that's your quiz for today.